Welcome to the deep dive. All right, so today, you listeners, you've sent us down a pretty fascinating kind of sci-fi sounding rabbit hole with this whole idea of absolute zero propulsion.
It does sound pretty wild, doesn't it? Harnessing the very stillness at the heart of matter to, maybe someday power starships. It's a pretty bold idea.
It really is. I mean, we're not talking about the typical rocket fuel explosions, adding energy to make things go boom.
Right, right. It's a completely different concept. More like coaxing out this energy that's already there, locked away inside atoms.
Exactly. Tapping into the fundamental forces that hold everything together, the very fabric of the universe kind of stuff. But like without blowing it all to smithereens.
That's the trick, isn't it?
Yeah.
So where do we even begin with the concept,
Yeah.
this massive? I mean, your notes here mention atoms and absolute zero and all sorts of mind-bending physics.
Yeah. And honestly, when we first saw this topic request, even we were like, whoa, okay, this is next level. But that's what we love about the deep dive, right? Exploring these bleeding edge ideas. So our mission, if you want to call it that, is to really try to understand this whole absolute zero propulsion thing based on what we've all been reading about.
Sounds like a plan. So let's start simple. Let's talk atoms. I mean, we all remember that stuff from high school, right? Tiny little balls bouncing around.
Right. But they're not really little billiard balls, are they? I mean, based on the research you've been digging into, it's way more complicated and way more interesting than that.
Oh, absolutely. Atoms are constantly moving, vibrating. It's more accurate to think of them as waves or like these fluctuating energy fields.
So not so much solid little things, but more like, I don't know, tiny little bundles of energy constantly buzzing.
Yeah, that's closer to the picture. And here's where it gets even more interesting. These waves, they're not just doing their own thing. They're all tangled up, kind of like, well, imagine a whole bunch of those strings of Christmas lights all jumbled together in a box, all glowing and flashing.
Entangled. Like they're all connected somehow.
Yeah.
So one little wave does something, and it affects all the others.
Exactly. And the research talks about this entanglement forming these really complex patterns, fractal patterns. It's a bit like, well, those Russian nesting dolls, how each one is a smaller version of the bigger one. It's like that, but with energy, repeating patterns at different scales within the atom.
Whoa, okay, that's a lot to wrap my head around. So we've got all this energy, all these interconnected waves inside every single atom, and it's not random. There's a pattern, a structure to it. So what happens because of all that motion and entanglement? What does it actually do?
Well, it creates these, well, you could call them polarized ends within the atom, areas of positive and negative charge. And that polarization, those positive and negative bits, that's what allows atoms to stick together to form molecules. That's basically how you get everything from water to rocks to, well, to us.
So the entire universe, everything we see and touch, it's all held together by these tiny little bundles of entangled vibrating energy. I mean, that table over there, the air we're breathing, it's all just a bunch of atoms doing this crazy dance.
Oh, you got it. But here's the kicker. All that motion, all that entanglement, it means there's a huge amount of energy bound up inside each atom.
Okay, so that brings us to the million-dollar question, right? How do we get at that energy? But, and this is key from what I've read, how do we do it without just smashing the atom apart like in a nuclear bomb?
That's the elegance of the absolute zero propulsion idea. It's not about brute force. It's about, well, it's almost like gently unwinding those entangled waves within the atom.
Unwinding, like carefully unraveling a knotted-up necklace or something.
That's a good analogy, actually. Instead of adding energy to break things apart, the idea is to create the right conditions where the atom kind of releases that energy on its own. And that's where absolute zero comes in.
Okay, hit us with it. What exactly is absolute zero?
So absolute zero is theoretically the coldest anything can possibly get.
Yeah.
It's zero on the Kelvin scale, which is like minus 273.15 degrees Celsius. And at that temperature, everything stops moving, like completely stops.
Whoa, everything. Even those crazy little waves inside the atom.
Theoretically, yes, everything would just freeze in place. And at that point, the forces that usually hold the atom together, those positive and negative charges we talked about, they become super weak.
So if we could somehow get matter down to absolute zero, we could weaken the bonds holding atoms together and potentially, I don't know, make those entangled waves unravel more easily.
That's the basic idea. And when those waves unravel, they release energy. It's not like an explosion, more like these focused shockwaves, like ripples spreading out from a point.
Shockwaves. Okay, so not a constant stream of energy, but more like these sudden bursts. And the idea is to, what, capture those shockwaves somehow and use them for, well, propulsion.
Yeah, that's the big audacious goal. A spacecraft that moves not by burning fuel, but by carefully manipulating the very energy that holds matter
I
together.
mean, that would be game-changing, to say the least.
Hmm.
No more lugging around tons of rocket fuel, no more fiery exhaust plumes, just pure, clean energy from the very heart of matter. But, and there's always a but, right? Getting down to absolute zero, that's not exactly a walk in the park, is it?
Definitely not. I mean, the technology to even get close to absolute zero is super complex, super expensive.
And the closer you get, the harder it gets, right?
Yeah.
Like exponentially harder. It takes more and more energy to cool things down that last tiny fraction of a degree.
Yeah, it's a huge challenge. And it's not just the energy. Working with things at those temperatures, it's like trying to build a house of cards in a hurricane. Everything is incredibly sensitive. Even a little vibration, a tiny bit of heat, could mess everything up.
So while this whole absolute zero propulsion idea sounds mind-blowingly amazing in theory, actually making it work, that's a whole other level of,
Yeah.
well, of everything.
It's definitely a long-term goal. But, some of the most important discoveries in history, they started as crazy ideas that seemed impossible. And think about it, even if we don't crack absolute zero propulsion anytime soon, just researching it, just trying to figure out how it might work, that could lead to all sorts of other discoveries, other breakthroughs.
Absolutely. Think of all the technologies that spun off from the space race, for example. Things that we use every day that wouldn't exist if we hadn't pushed the boundaries of what we thought was possible. And that's what's so exciting about this, is pushing the limits of science, forcing us to think in completely new ways about energy, about matter, about the very nature of the universe.
Exactly. And who knows, maybe someday we'll look back at this conversation, this deep dive into absolute zero propulsion, as the moment that sparked a whole new era of space exploration, maybe even interstellar travel.
Now that's a thought. So for our amazing listeners out there who've stuck with us on this wild ride, let's recap, shall we? We've been talking about this radical idea of extracting energy not by breaking things apart, but by tapping into the energy that's already there, bound up inside every atom, and using that for propulsion.
And the key to that might be absolute zero, that theoretical point where everything stops moving.
But it's not just about reaching that temperature, right? It's about
Uh,
understanding the complex dance of energy within the atom, those entangled waves,
mhm.
and figuring out how to manipulate them in a controlled way to release that energy.
Yeah, it's like a cosmic puzzle box.
Yeah.
And we're just starting to figure out the first few steps, but the potential payoff, it's huge.
Potentially a universe of possibilities, right? And maybe, just maybe, that journey begins with a deep dive like this, with a spark of curiosity, with a willingness to explore even the seemingly impossible. So we leave you with this. What if we could truly tap into the fundamental energy of the universe? What would that mean for humanity? What would that mean for our understanding of our place in the cosmos? Something to ponder, right? Thanks for diving deep with us.